I discuss about the fifth unit of network signals and systems. So under this network signals and systems, what are the main contents on this fifth unit is, what are the parts of network functions? So under this network functions, driving point impedance functions, driving point admittance functions. What is the basic relationship of this impedance and admittance? Like this, we have to see in this about the parts of networks functions. And then that is next one is synthesis of two-port networks. And this synthesis of the two-port networks, we will discuss about the what is impedance, that means open circuit, short circuit impedance and admittance parameters in terms of the LC networks and RL networks and RC networks. For that we discuss about the different techniques, that is fast 1, fast 2 and cover 1 and cover 2. These topics will related for the synthesis of the two-port network. And then we discuss about the Fourier series. What is Fourier series? How we have to find out the coefficients of the Fourier series, that is A0, AN and BN, and what is the even and odd functions of this Fourier series, and some related problems about this Fourier series. And then next topics, what is Fourier transforms, what is Fourier transform, what is the relation of Fourier transforms, and what are the different properties of this Fourier transforms. So in this unit we discuss about the what is the parts of the network functions, what is the synthesis of the two-port network, and what is Fourier series, and what is Fourier transforms. So in this class I discuss about the what are the different parts of network functions. Generally in the network functions, that is the for two-port networks, that means if there is a one pair of terminal, then it is called as one port network. If there is a two pair of terminals must be there, that is called as two-port network. Under this already we discuss about the what is the open circuit impedance parameter and short circuit admittance parameters. So under this open circuit and short circuit parameters, already we discuss about the what is the basic relationship of this Z and Y parameters. In terms, when you have to know about the Z parameters, how you find out the Y parameters, and when you have to know about the Y parameters, how to find out the Z parameters. So under this two-port network functions, there is basically driving point functions and transfer functions. So basically it will be divided driving point functions and transfer functions. So under these driving point functions, there is driving point impedance functions. Driving point impedance function. Impedance is denoted by the letter Z. It is the ratio of the voltage by current is nothing but the impedance. And another one is driving point admittance function. So driving point admittance function means it is related by letter. Admittance will be Y, and the reciprocal of impedance is nothing but the admittance. Admittance is the ratio of current by voltage, is nothing but the driving point admittance parameter. So under the driving point functions, there is driving point impedance function and driving point admittance function. And then next one is transfer functions. Under this transfer functions, voltage transfer function, current transfer functions, and transfer impedance functions, and transfer admittance functions. So under this basic two-port networks, there is related to two-port parameters must be there. So under these parts of parameters, parts of functions, there is driving point functions and transfer functions. Under that driving point functions, there is driving point impedance function is the first one, and the driving point admittance function will be the second one. Under the transfer function, there is voltage transfer functions, current transfer function, transfer impedance functions, and transfer admittance functions. So now we see about the one by one. So what are the different parts of this function? So network functions gives the relationship between currents or voltage as driving point and transfer functions. Whatever the driving point functions are there, whatever the transfer function are there, what is this means? It will be shows the basic relationship. What is the basic relationship in terms of voltage and current in terms of driving point or transfer functions? So driving point functions is the excitation and response are measured at same port. The network function are known as driving point functions. When there is the, it will be what driving point function means, it will be the excitation and it will be show the excitation and response measured at the same port. The network are known as driving point functions. Driving point functions. So this is a the two terminal linear network. So under this there is one terminal, there is only one pair of terminals, that is voltage source is V of S and current will be I of S. In two pair of terminals there is two pair of terminals must be there. The first one, the input terminals you have taken as V1 of S and I1 of S, and the second term the output terminals we have taken as V2 of S and I2 of S. That means in the two port network there is four variables must be there. So under these four variables, first when you have to we consider two variables or dependent variables and two variables or independent variables. That means if one thing when you have to write down in terms of voltage impedance form, that is the Z parameter, V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. In terms of the current source, that means when you have to write down in terms of the admittance form, then we have to write I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. So like that you have to write down in terms of impedance parameter and admittance. There is the four variables you have to there is V1 V2 and I1 I2. In these four variables we have to consider two are at the time, two are in the independent variables and two are in dependent variables. Not only the impedance and admittance parameters, you have to write Z, impedance Y, admittance parameter H, hybrid parameters ABCD, transmission parameters, inverse hybrid parameters and inverse ABCD parameters. These all write in the form of the four variables, that is two will be considered the dependent and two will be considered the independent variables. So driving point impedance function is defined as the ratio of Laplace transform of voltage at the port and the current at the same port. So driving point means driving point will be considered in the same port voltage, same port current. Driving point, if suppose the first port there is V1 and I1, so how you have to driving point, it is the ratio of voltage by current in the same port, that is Z of S is equal to V of S by I of S. V of S by I of S is nothing but driving point impedance. So driving point impedance means it is the ratio of the voltage by current. When you take the admittance, it is the ratio of current by voltage. So it is defined as ratio of Laplace transform of current at the port of voltage at the same current at the port and the voltage at the same port. Both are in whatever the driving means, it will be considered the same ports. Either it will be the input port or it will be the output port. You have to consider in the same port. So driving point impedance means driving point impedance is nothing but Z of S is equal to V of S by I of S. In the admittance, Z of Y of S is equal to I of S by V of S. I of S by V of S. So impedance voltage by current, it is mentioned in the form of Z, and admittance current by voltage, it is mentioned in the form of Y of S. Z of S is equal to E of S by I of S and Y of S is equal to I of S by V of S. And next, so for a two-port network, the driving point impedance functions are Z11 of S is equal to V1 of S by I1 of S. Z22 of S is equal to V2 of S by I2 of S. Same thing, driving point admittance functions are y11 of S is equal to I1 of S by V1 of S, and y22 of S is equal to I2 of S by V2 of S. So when you consider the impedance function at the two-port network, the same ports will be related to the, either it will be the voltage or current, whatever it may be there, it will be related to the same ports. Either it will be related to first port or it will be related to second port. So when you have to consider the impedance function, it will be considered the voltage by current. When you have to consider the admittance function, we have to consider it the current by voltage. So the driving point impedance functions are Z11 of S is equal to V1 of S by I1 of S, where Z22 of S is equal to V2 of S by I2 of S. Same thing, the driving point admittance functions are y1 of S is equal to I1 of S by V1 of S, and y22 of S is equal to I2 of S by V2 of S. Same thing, transfer function. Driving means you have to consider the either the input port or the basic values must be related to the either the input port or it will be the either the output port. Both are related to input or both are related to output. Short transfer means the input, the voltage of the input port and the current of the output port, or current of the input port or voltage of the input. That will be called as transfer function. Transfer function is defined for the network that it has at least two ports. It is related to voltage or current at port to voltage or current at the other port, to that port or other port. They are also defined as ratio of Laplace transform of response to excitation. That means Z12 is equal to V1 of S by I2 of S. Z21 of S is equal to V2 of S by I1. So that means transfer function it will be related to the voltage of the first port and the current of the second port. That is the impedance. When you have to take admittance, the current of the first port and the voltage of the second port. So transfer function means is defined as a network at its two para ports is related to voltage or current at one port to voltage or current at the other port is nothing but the transfer function. So Z12 of S is equal to V1 of S by I2 of S, and Z21 of S is equal to V2 of S by I1 of S. V2 of S by I1 of S. So transfer impedance function is defined as the ratio of Laplace transform voltage at one port to the current at the other port. The voltage of the first port and the current at the other port. So Z12 of S is equal to V1 of S by I2 of S, or Z21 of S is equal to V2 of S by I1 of S. Same thing. This is the impedance function. So when you have taken the admittance function, transfer admittance function is defined as the ratio of Laplace transform current at one port and the voltage at the other port. That means the current by voltage is nothing but the admittance. So we have to consider whatever the current at the first port, you have to consider the voltage at the second port. When you have to consider the voltage at the first port, you have to consider the current at the second port. So y12 of S is equal to I1 of S by V2 of S, and y21 of S is equal to I2 of S by V1 of S. So transfer impedance function is defined as the ratio of voltage at one port to the current at the other port. That means Z1 of S is equal to V1 of S by I2 of S, and Z21 is equal to V2 of S by I1 of S. where transfer admittance function is defined as the ratio of Laplace transform current at one port to the voltage at the other port. So Y12, Z12, there in the driving Z11, Z22, Y11, Y22. Here when you observe here Z12, Z21, Y12, Y21. So Z12 is equal to V1 of S by I2 of S. Z21 is equal to V2 of S by I1 of S. Similarly, Y12 is equal to I1 of S by V2 of S, and Y12 is equal to I2 of S by V1 of S. So, and this voltage transfer ratio, or it is called as voltage gain. So the relationship between the two voltages is nothing but the voltage gain. So it is defined as a ratio of voltage at one port to the voltage at another port. Voltage at one port to the voltage at another port. So G12 of S is equal to V1 of S by V2 of S. It is defined as a ratio of Laplace transform of voltage at one port to voltage to the voltage at the other port, that is G12 is equal to V1 of S by V2 of S, V1 of S by V2 of S, and G21 of S is equal to V2 of S by V1 of S. V1 of V2, 1 2 means 1 of S by 2 of S, and 2 1 means 2 of S by 1 of S. But voltage transfer function is defined as the voltage at the one port to the voltage at the other port. So G12 of S is equal to V1 of S by V2 of S, and G21 of S is equal to V2 of S by V1 of S. And current transfer function, it is current gain. So current transfer function is nothing but it is the ratio of the current at one port to current at the other port. The same currents we have to be ratio, then it is called as current transform ratio. When you have to be voltage transform ratio means we have to be divide the voltages of the first port and the voltage of the second port, and when you have to take in the current transform ratio, it is defined as the ratio of the current at one port to current at the other port. So in the voltage transform ratio, V1 of S is by V2 of S, G12 is equal to V1 of S by V2 of S, G21 is equal to V2 of S by V1 of S. When you consider the current transformer ratio, A12 is equal to I1 of S by I2 of S, and A21 is equal to I2 of S by I1 of S. So in the voltage transformer ratio, what is defined as the ratio of voltage at one port to voltage at the other port. So it is voltage of first port by current voltage of second port, or it will be voltage of second port by voltage of first port. And at the current transformer ratio, it is defined as the ratio of the current at one port to the current at the other port. So it is the current of the first port by current of the second port to current of the second port to current of the first port. So under the transformer driving point, port 1 voltage and current, and port 2 voltage and current. When you take the impedances, Z11 is equal to V by I, V1 of S by I1 of S. Port 2 is Z22 is equal to V2 of S by I2 of S. When you take admittance, I11 is equal to I1, Y11 is equal to I1 of S by V1 of S. Same thing, I22 is equal to I2 of S by V2 of S. It is related to the same port, then it is called driving. Same port voltage and same port current will be driving. Same port voltage and same port current will be driving point impedance. When the transfer function is Z, Y, G and alpha, then you have to take this V1, I1 and V2 up to transfer function of Z21 and Y21. Transfer admittance is Y21 denoted by voltage transformer ratio G21, current transformer ratio A21 or alpha 21. So means the ratio of voltage transform at output port to the transform of the current at the input port. That is Z21 is equal to V2 of S by I1 of S. And second one, the ratio of transformer admittance means the ratio of current at one port to the second port to the voltage at the input port. Current at output port by voltage at the input port. So Y21 is equal to I2 of S by V1 of S. And voltage transformer ratio. So the ratio of voltage at the output port to current at the voltage at the input port is nothing but the voltage transformer ratio. That is G21 is equal to V2 of S by V1 of S. Next, current transformer ratio. The ratio of current transform at output port to the current transform at the input port. So, alpha 21 is equal to I2 of S by I1 of S. So, driving point means it will be related to the same ports. It's nothing but the driving point. So Z11 is equal or Y11 V1 by I1S V1 of S by I1 of S. Y11 is equal I1 of S by V1 of S. And Z22 is equal to V2 of S by I2 of S. And Y22 is equal to I2 of S by V2 of S. When you take the transfer, the voltage of the first port and the second of the second port. So transfer impedance means voltage of the second port by current of the first port. Transfer admittance means current of the second port by voltage of the first port. And voltage transformer ratio means voltage of the second port by voltage of the first port. And current transformer ratio means current at the second port by current at the first port. And we see about the some examples of this determine driving point impedance of the given function. So here they have to given resistor, inductor and capacitor. So you have to write down the driving point impedance. So when you observe that for resistor there is no change. So when you have there is resistor you put R. So when there is the inductance or capacitance must be, there is the change must be there. So when you have to take this inductance, V is equal to L di by dt. So when you have to take Laplace transformer, V of S is equal to L into S into I of S by I of 0. So initial it will be 0. So V of S is equal to S into SL into I of S. So V of S by I of S is equal to L into S. L into S. L into S. I of S by V of S is equal to 1 by Ls. I of S by V of S is equal to 1 by Ls. Next, impedance in the inductance is Ls. Admittance in the inductance is 1 by Ls. Impedance in the capacitance is 1 by Cs. And admittance in the capacitance is Cs. Like this, we have to be observe this. So, driving point impedance of this function. So, we have to convert this. So, apply Laplace transform. Z of S is equal to 1 by SC into R plus 1 R plus Ls. So, Z of S is equal to ratio 1 by SC plus R plus Ls. L into S, because when you have to impedance for the inductance is L into S. Admittance for the inductance 1 by Ls. Impedance for the capacitance is 1 by Cs. Admittance for the capacitance is Cs. So Z of S equal to 1 by SC into R plus Ls by 1 by SC plus R plus Ls. So Z of S is equal to R plus Ls by SCS cancels. So RCS plus LCS square plus 1. So Z of S equal to 1 by C common, then you get R by L plus S by S square plus R by LS plus 1 by LC. So we get the total. How you find out the impedance of this function? Z of S equal to 1 by C into R by L plus S by S square plus R by LS plus 1 by LC. At the following one port network, find the transfer function. So they given the network resistor and inductor. Here also resistor R2 and L2, but it is in series, it is in parallel. So figure 1, when there is the resistor R1, you put R1 also, because impedance. When there is inductance, we put S into L1, S into L1. So that network is in series. So how you find out the impedance? So Z of S is equal to R1 plus S into L1. R1 plus S into L1. So when you have to write down in the form of the admittance, they ask impedance and admittance. So impedance is equal to, both are in series, but the resistor you have to write simply in resistor. Inductor you have to write in the form of the S into L1, S into L1. So Z of S equal to R1 plus S into L1, and the driving point admittance is Y of S equal to 1 by ZS, that is 1 by R1 plus SL2. Like that, when you observe in the figure 2, R2, L2 are in parallel. So simply in impedance form, R2 is equal to R2 and L2 is equal to S into L2. So when both are in parallel, then how you have to write? Product of the impedances by sum of the impedances. So impedances of parallel is network is equal to ZA ZB by ZA plus ZB. So what is ZA? RA SL2 by R2 plus R2 into SL2 by R2 plus SL2. When the driving point impedance is reciprocal of the impedance is nothing but the driving point admittance. So 1 by Z is equal to reverse R2 plus SL2 by R2 SL2. Next, determine the transfer impedance. They ask only transfer impedance. Here there is the resistor and inductor and two resistor and inductor. So the transfer impedance means current voltage at the first and the current at the second pole. V2 of S by V1 of S. So writing the network components, R1 is R1, R2 is R2, but L is equal to S into L. V is equal to V1, V2 is equal to V2 of S. So I1 is equal to I1 of S and I2 equal to I2 of S. We can write the KVL equation with the port 2 as open circuit. First you have to write open. When it will be the open, the inductance becomes 0. With port 2 open circuit, I2 current will be 0. Therefore, two loop equations V1 of S is equal to I1 of S into R1 plus R2. V2 of S is equal to I of S into R2, because here the inductance must be 0. When you have to take in the first loop, V1 is the current, I2 is 0. I1 of S into R1 plus R2 are in series. So when you have to find out the current, that is I1 of S, the voltage of V2 of S. When you have to write down the voltage of V2, the parallel of V2 is R2. So V1 of S equal to I of S into R2. So the transfer impedance is equal to G2 of S is equal to V2 of S by V1 of S. That is equal to I1 of S R2 by I1 of S into R1 plus R2. So that is equal to R2 by R1 plus R2. Same thing, the transfer and driving point impedance is nothing but Z11 is equal to V1 of S by I1 of S. So V1 of S is equal to I1 of S into R1 plus R2. So Z11 is equal to V1 of S by I1 of S is equal to R1 plus R2. R1 plus R2. Like that you have to find out the transfer impedance parameter. Next, the another, determine the transfer functions and the driving point impedance of the following. So here also they given inductance is 2 inductors and 1 resistor and 1 capacitor. So first we have to network the parameters in terms of L1 is S into L1, L2 is S into L2, C1 is 1 by S C1, V1 is V1 of S, V2 is V2 of S, and I1 is I1 of S. So with output port, I2 must be equal to 0. Whenever you have to put 0, L2 must be 0. Then I1 V1 of S equal to, these three are in series, L1 S into L1 plus R1 plus 1 by SC1 into I1 of S. So that is equal to S square L1 C1 plus S into R1 C1 plus 1 by S C1 into I1 of S. So V2 of S, when you have to find out the voltage of this port, across this port there is R1 and C1 of S. So 1 plus S into R1 C1 by S C1 into I1. So the transfer function G2 of 1 is equal to V2 of S by V1 of S. That is 1 plus S R1 C1 by S C1 by S square L1 C1 plus S R1 C1 plus 1 into by S C1. So that is equal to 1 plus S R1 C1 by S square L1 C1 plus S into R1 C1 plus 1. So Z11 is equal to V1 of S by I1 of S. So we get the equation S square L1 C1 plus S R1 C1 plus 1 into SC1. So they ask the driving point impedance and transfer impedance. Driving point impedance means you have to find out Z11 is equal to V1 by I1. Transfer impedance you have to find out Z12 is equal to V1 by I2. So for that purpose you have to put I2 must be equal to 0 and you have to find out. So in this unit we discuss about the two-port parameter, two-port functions. Under the functions we discuss about the what are the network function depending upon the driving point functions and transfer functions. So driving point means it will be related to whatever the parameters must be there, that will be related to same port, then it is called driving point impedance or driving point admittance parameter. Transfer impedance and transfer admittance means the port which will be related to voltage of the first port and the current of the second port is nothing but the transfer impedance or transfer admittance parameters. So this is about the topic of this parts of network functions. Thank you.